So basically you have to know about sigma, you have to know about rho. Okay, so sigma was what? Ne square a tau divided by m, and what was rho? I take reverse of this, so m by ne square a tau. This is sigma and rho, and you can say r is what? Equals to rho L by A, and resistance will change according to temperature as r equals to r naught 1 plus alpha delta T, and rho will change as rho equals to rho naught 1 plus alpha delta T. Afterwards we understood how to deal with the circuit when resistors. You need to find out equivalent resistance in balance condition, and afterwards we also learned about how to find out deal with the resistance in unbalanced condition. Next, about we will understand about KCL, Kirchhoff's current law. So this is very important. Suppose current is coming here I1, and this is I2, and this is I3. So this is what basically node. This is what node. Okay. So at any node, sum of all the current will be 0. So we'll say it I1 plus I2 plus I3 equal to 0. So we'll apply this, okay, here for solving a circuit. So this is 2 ohm, this is 2 ohm, this is 2 ohm, this is 10 volt, this is 10 volt, and this is 100 volt. So we need to find out the current. Okay, this is A, B, C, D, E, F. To solve this question, you can take any point as a reference point. Okay, 0 volt. Okay, you can take any one, but try to take the point, the reference point which is connected to the more and more number of wire. Okay, so see, if you see, this is connected through this point, this and this, so I'm taking F as 0. So this is 0, so this is again, this will come here 0, so this is 0 volt. Okay, this is 0 volt. Now you can take, try to write the known voltage and try to put the values to the other point. Okay, so this is 0, this is 10 here, this is plus and this is minus, so you have to consider later on this one. So second terminal, so 0 plus 10, so you here what will be the voltage? 10 volt. Okay, here it will be 10 volt, and this is 0 and here 10. So here at this point it will be what? 10 volt. At this point it will be at 10 volt, because this is plus, so I'm adding this. Okay, so always consider secondary terminal, always consider secondary terminal. This is going to be, okay, just assumptions. You can also take first, some people also take first terminals, but therefore that you have to change all the sign convention. But I'm taking second terminal, just I'm adding it. Okay, so this is 0, so this is 100, so add it 100. This is 100, 100, 100, so at this point you will get 100 volt. Okay, so at basically B point you will get 100 volt. Now see, you know the point potential here as well. Okay, here is 100 volt, and you also know the potential here is 10 volt. You also know the potential here is 10 volt, but you don't know potential over here. So suppose I take this point is C, and suppose I take here the potential is X. Now I need to find out current. Okay, everywhere. Okay, suppose, so now we, if once we will get the value of X, so we can find out the current everywhere. Okay, so it's easy to solve. So now I'm going to apply this KCL. So see, this is X minus 100, apply. So X minus 100 is voltage difference, so X minus 100 divided by 2, this is current. Okay, plus X, and this is 10 volt, so X minus 10, so this is X minus 10 and divided by 2. Okay, so this and here see X minus 10 again, so plus of X minus 10 and divided by resistance is 2 ohm, so I'm applying here 2 ohm, and this will be equal to 0. If you solve this equation, you will get the value of X, and once you put the value of X in the circuit, okay, in the circuit, then you can, okay, solve the value. Okay, so see here, so here everywhere is 2 to 2, it will goes to right side and it will multiply by 0, so it will goes 0, so I am directly solving it. So X minus 100 plus X minus 10 plus X minus 10 equal to 0. So see, x plus x plus x, 3x. So this is 3x and minus 100 minus 10 minus 10. So this is what, minus of 120 equal to 0. So here what is x? X is what, 120 divided by 3. So this is what, 40. So basically this is x is what, 40 volt. This is what, 40 volt. Now you, once you got the 40 volt, now you can find out current everywhere. Suppose I want to find out current. This is I1 and this is okay I2. You may ask what about the direction. So no need to worry about direction. See, current will be from high potential, goes from higher potential to lower potential. This is 100 volt, this is 40 volt. Current will go in this direction. This is 40 volt and this is 10 volt here. So here current will goes in this direction. Here 40 volt, this is 10 volt. Current will goes in direction. Even you will not assume this, it automatically it will come negative sign, so no need to worry about it. But because I am okay observing over here, that's why I directly wrote the direction. Okay, now this direction is 100% correct, there is no error in it. Okay, yeah. So what is current I1? So I want to find out current in I1. So 100 and minus of 40 volt. This is what, 40 volt. So 100 minus of 40 and divided by what is resistance, 2 ohm. This is 2 ohm. Okay, all resistance was 2 ohm. This is 2 ohm and this is 2 ohm. So just to divide by 2. So 100 minus 40 is what? 100 minus 40, 60 by 2, 30 ampere. So I1, I'm writing here the current. So I1 is what? 30 ampere. 30 ampere. Okay. Now see, here you need to find out okay the current. So this is what, 40 volt and this is what, 10 volt. 10 volt. So you need to find out this is I2. I'm assuming this as I2. So I2 is what? I2 is what? 40 minus ka 10. 40 minus ka 10 and divided by 2. So this will be what? 40 minus 10 is 30 by 2. 15 ampere. So this is 15 ampere. So I2 is 15 ampere. Now I'm finding here the current is I3. Suppose this current is I3. So I take this as I3. I3 is what? Okay, this is 40 volt, this is 10 volt. 40 minus 10 is what? 30 volt and divided by 2. So divided by 2, so this is what? 15 ampere. Okay, so I3 is 15 ampere. So I already mentioned the direction in the circuit over here, and you can also verify it. Okay, incoming current is going to outgoing current. So also some of people apply this real theories that I incoming is equals to I outgoing. So this is same thing, you take this on this side and it will add it. Okay, it will come with negative sign, and because outgoing is obviously, so you take incoming plus outgoing will be minus. So minus minus plus, automatic theory is same, but it depends on you what you like and how you apply it. Okay, so this is 30 ampere. So see, you can apply this here. So 30 ampere is coming, 15 ampere is going, 15 ampere is going, so it's satisfied. So by this way, if you solve the questions, you can solve so many problems. Okay, very good manner. Okay, so this is known as KCL. This is the best way to understand the KCL, Kirchhoff's current law, or this is also we say node analysis. So node analysis, you have to understand any for node analysis, then only you can move and you can play with the chapter. Otherwise it will be difficult for you to understand the things. Next is loop analysis. Okay, loop analysis. Okay, so loop analysis is also we are applying loop analysis. So this is what we are applying the voltage. We are playing with the voltage. Okay, so you can also say this is voltage analysis. So basically what happened, we have a circuit over here, and basically you have to understand the basic thing first. Okay, so suppose we are I'm solving this question, how to apply the loop law. See, this is A and B. So this is one branch. In any branch you have to follow these rules for any branch. Okay, so right now I'm applying for this branch. Okay, so this is okay, V of, suppose this is V volt and this is R. Okay, so I need to find out the apply this law for a certain branch, and we'll complete this whole circuit. So see, here voltage we don't know, so this is VA. I start with VA. I said already you that I am assuming second terminal of the battery, so you can also assume first terminal, but no. Okay, so you have to change all the sign convention over there, but I am assuming all these things. So if you take second sign convention second terminal, so in the direction of current flow, potential will decrease. Okay, potential will decrease. So you have to write with minus sign. In the direction of current flow, you have to write with minus sign. In opposite direction of current flow, you have to write with plus sign. So see here, VA, and this is minus, and this second terminal. So VA minus of B. Here in the direction of current flowing, potential will reduce. So I am writing it minus of I into R, and this is equals to VB. So you can write like this. This is equals to VB. When I apply this, you can take potential difference between A and B. So VA minus VB equals equals to V plus IR equals to, okay, so V plus IR. So basically what is the potential difference between A and B? So this is connected to another source and whatever. So basically what is the potential difference A and B? So this is B plus IR. So if you understand how to apply it, now I'm going to apply this for a complete loop. So basically we can apply this rule for a complete loop only. So this is 2 ohm and this is 2 ohm and this is 4 ohm and this is 40 volt and this is 20 volt. So I want to find out current, okay, in this circuit. So see, you have to focus on the loop. So loop A B C D. So this is one loop, you can take it, and this is B and B C and D E. So you can take another loop. You can go clockwise, anti-clockwise, it depends on you. But okay, you have to assume the current. You have to assume the current. You have to assume the current. So what I am saying, suppose okay, from here, okay, current is going in this circuit, okay, current is going I1, okay, suppose I take this is I1 current. So I1 current is coming here, I1 current is coming here. So here suppose I2 current is going, I2 current, or suppose this is I current, so this is I1 current is going here, I1 current is going here. So what current will goes here? I minus I1. You can write by any means, but I am using this convention. So I current is coming in this branch, and here at this point, this node I1 is going in this branch, and then I'm using KCL over here. So this I1, I is total current, incoming current, I1 is going. So I just subtracted I minus I1. You can write I2, but it will, okay, increase your burden. You have to create 3 equation for that. But you see here only 2 unknown, I1 and I. So you can solve this equation only by creating 2 equations. So I'm assuming one loop is this and one loop is this. So now you have to keep patience, then only you can solve this, because there are a lot of chances to make it error. Okay, so there are so many possibilities, so that there will be so many errors over here. So you have to focus on mathematical point of view as well as conceptual point of view. So right now I am considering ABCD, loop ABCD. So see here, loop ABCD. In loop ABCD I am starting from point A. So in the direction of current, right, potential will decrease. Always keep in your brain. If you coming this side, opposite of the direction, the potential will increase. Okay, so here current will in potential will reduce, and by what amount? I2 into I, and this is plus, this is minus. In the direction of current, potential will reduce. So write with minus and minus of 2I. This is completed over here. This is battery 40 volt. This is, you have to see how to our second terminal. So this is minus 40 volt, right here minus of 40 volt, and come this side, and this current will go. So okay, see, so this. So this current is I. So this current here is what? I current only, yes or no? In this branch, from this point to this point, I current will be there only, yes or no? And here no resistors, so no use of I minus I1. Okay, so okay, that's why no, this term is not coming over here. If there will be a resistor over here, so you have to take this current here. So this is I current. I am assuming this current here coming, so 2I. So in the direction of current we are going, in the direction of current we are going, in the direction of current we are right with minus of 2I equal to 0. So see, beauty of this question is that because there is no resistance over here, so from here directly you can solve the questions, because there is no resistor over here. Otherwise, if there is another resistance, you have to solve it. Okay, for you have to wait for the other equation, then only you can solve it. Because I look over here, so I'm first solving it. So what is this? 2 plus 2I, 4I plus 40 equal to 0. So basically what is coming? I is coming minus of 40 divided by 4. So this is minus of 10 ampere. Why this is coming minus of 10 ampere? It shows that whatever direction we took, that is okay, wrong assumption. So basically actual current will flow in this direction, and therefore value will be 10 ampere. So the basic thing and good thing of this theory is that you no need to worry about the direction. Automatically it will come in the picture. Now I'm going to analyze the loop, this one, BDEC. So loop BDEC, see here, loop BDEC. In loop BDEC I'm starting from point B. So in the direction of current I'm going, so in the direction of current, okay, because our assume current I1, so we have to follow that our assumption only, no need to worry about what is reality. So this is what minus of 4I1, and this is current, and you see a plus of 20, and come, there is no resistor over here. Come this side, okay, plus of 40, and equal to 0. Now see, here again only one unknown, so you can solve it directly. So this is minus of 4i1 minus of 4i1, and this is 40 plus 20 plus of 60 plus of 60 equals to 0. So from here 4i1 is 60. From here I1 is what? 3 by 2. So this is 3 by 2 ampere. So from here, so now you can see. So this is 3 by 2 ampere, means this assumption is correct. Okay, so in this circuit 3 by 2 ampere current is going. If you find out I1, no need to worry about sign again for this branch as well. So I want to find out R minus I1. So what is I? So you have to take the with minus sign. Okay, basically now you don't want to take minus sign, just apply the concept. Okay, this side 10 ampere is going, this side 3 by 2 ampere is going. So this is going outgoing current, and there will be current. So it means, so this current is coming from this side, and what is coming? This plus this plus this. Are you getting my point? What I'm saying? So this current will come from this side, then go outgoing current. So income, there should be incoming current is what? This plus this. What is I'm solving here? So what is incoming current? 10 plus of 3 by 2. So if you solve it, this is 20 plus 23 by 2. So this is incoming current. This is again, okay, this whatever we assume direction, that is wrong. So this is the, okay, means that was incorrect, our assumption was correct. So 23 by 2 ampere will come like this. Okay, if you want to solve from here, just put with sign, no need to worry about it. I is what? Minus of 10 ampere. So minus of 10 ampere, and what is I1 is what? I1 is, this is 3 by 2 ampere. So minus 3 by 2, if you solve it again, minus 23 by 2 ampere. It is coming with minus sign because you have to take the reverse sign. So if you understood how to play with the sign, it will improve your confidence, because it's very important to understand to play with the sign. Okay, so once you know how to play with sign, you become, okay, expert of this topic, and you can play with any questions. So I have covered up to the advanced level. You can solve any questions if you know, and even if you are not compatible with it, you can go with the basics and you can solve all questions. No need to worry about it. Yeah. So now what we understood, KCL is what? Based on what? So question comes that KCL based on conservation of, so KCL following based on conservation of charge, because we are talking about current is what? Flow of charge, rate of flow of charge. So KCL, current law, Kirchhoff's current law, is valid for the conservation of charge. But what about, we are talking about loop law. So loop law is basically based on energy. We are talking about voltage energy itself, EMF. So there we are trying to conserve the energy, and there we are trying to conserve the charge. So now we have covered almost everything. Now we are talking about Wheatstone bridge. So see here. So basically we have covered already Wheatstone bridge over there, that you need to take about this resistor. Okay, there will be no current in this. Okay, so galvanometer, there will be no current over here. This one by this one equal to this one or this one. So in during equivalent resistance we have already covered it. Okay, so now we are calculating equivalent resistance. There I already did the same thing. So basically what is happening, you have to do arrange this circuit in such a way that current through this is 0. So what is the rule for this? Ig should be 0. Again, if you want to prove it, easily you can prove it, but again apply the loop law in this, and this you can apply the rule. Loop law is very important, and a node analysis is very important. If you know node analysis, if you know loop law, you are the okay one. So yeah, so in this circuit, so this is, I'm taking R1, this is taking R2, this is taking R3, this is taking R4. So basically our Wheatstone bridge will be balanced. If the R Wheatstone bridge will be balanced, so what I'm saying, so this is going to be, just keep when R1 R2 equals to R3 by R4. After, okay, applying loop law, this result comes. The result is important. And current through this, okay, so this is galvanometer, so current through Ig is 0. So always you have to remember this condition for Wheatstone bridge. Okay, balanced Wheatstone bridge. Some other time Wheatstone bridge is also unbalanced. So no, you not to be, okay, rigid that only your Wheatstone bridge is going to be balanced. So in the situation Ig equals to 0. Some people also remember this one and multiply R1 into R4, R1 into R4, R1 into R4 equal to R2 into R3, R2 into R3. You can also say, so how we can apply for this concept for the application. So what I will give you a paragraph where I will say, we have a circuit design, we have circuit, and galvanometer is connected to the circuit, and reading of the galvanometer is 0. So this is galvanometer is connected over here, and reading of the galvanometer is, question is saying 0. This is 20 ohm, this is 24 ohm, and this is 14 ohm. And question is asking you what is the value of unknown resistance. Okay, so unknown resistance. Okay, question is mentioned you that in this circuit, this is circuit connected somewhere here. So in the circuit, in this circuit, current through galvanometer is 0. Current through galvanometer is 0. Current through galvanometer is 0. So current through galvanometer is 0 means what? Ig is what? 0. So Ig is 0. So you need to balance the circuit. So what? 20 divided by 24 and divided by 14 divided by R, because we already know the condition for the balance. Okay, we just don't bridge. So the either question is asking you the check the balancing and what is the current through galvanometer, so you have to say answer is 0. And already question is saying in the reverse direction that the current through the galvanometer is 0, so automatically it is informing you that the circuit is balanced. If the circuit is balanced, you have to take the ratio of resistance equal to ratio of resistance. So you can find out any resistance, any condition, you can solve it anything. So from here, if you solve it, so it will come like this: R equals to 24 into 14 divided by 20. If you solve it, 2, 10, 2, 7, and this is what this is tan. This is if you solve it, 7 into 4 is 28, 8, 2, 7 into 2 is 14, 2, 16, 160. You can check a calculation, okay? Don't trust me, okay? So this is what 16.8 ohm. So answer is 16.8 ohm. So now you understood also how to deal with the balanced, okay? How to deal with balanced Wheatstone race. Now we will talk about meter bridge. So basically what we are doing, this is we are connecting this resistance R1, and here we are taking another resistance R2, and here we are taking a meter scale. So basically this meter scale is of 1 meter, okay? So this is also known as meter scale, okay? Meter scale. This this strip is of 1 meter. So length of strip is 1 meter, means 100 centimeter. So 100 centimeter. So now, so this strip has some resistance, and that resistance, okay, will be mentioned in the question, so no need to worry about it, okay? Basically we are taking here galvanometer,